In March 1979, two NASA space probes, Voyager 1 and Voyager 2, moved along a trajectory near one of Jupiter's moons, Europa, as part of the Solar System Exploration Program. At a distance of 118,000 miles from the moon's surface, Voyager 2 took a number of high-quality images and conducted measurements that led scientists to hypothesize the existence of a liquid ocean beneath the thick ice shell of the moon. All subsequent research, including the data collected by the Galileo space probe in the late 1990s, while studying Europa at the height of 124 miles above the surface, confirmed the existence of a liquid water ocean beneath the ice, which is between 6 to 18 miles thick. Soon, thanks to the space probe studying Europa, scientists were able to discover something that gave them solid grounds to suggest that life might exist on this moon. On October 14, 2024, NASA launched the interplanetary mission Europa Clipper. This spacecraft is set to travel to Jupiter's moon and conduct detailed studies of its surface and subsurface ocean. This is NASA's most expensive planetary mission in history, the largest space probe ever designed for studying a planetary body, and the most ambitious mission in the search for extraterrestrial life in human history. What are the chances that we will discover extraterrestrial life? What exactly do scientists plan to find beneath the ice? And why has Europa Clipper become the most expensive project in NASA's history? Europa is one of the 95 moons of the gas giant Jupiter, a mysterious cold world with a diameter of 1,940 miles, which is about 90% the size of our moon. Entirely covered in ice, exposed to incredibly intense cosmic radiation, and with extremely low surface temperatures that drop below minus 50 degrees Celsius, it may seem like a barren, dead world at first glance. However, this icy moon is currently considered one of the most promising places in the search for extraterrestrial life. In 1997, while following an extremely low trajectory, just 125 miles above Europa's surface, the Galileo spacecraft managed to capture an extremely strange phenomenon. In one section of the moon's surface, there was something resembling a water vapor eruption. At the same time, scientists observed an anomaly in the readings from Galileo's magnetometer. Analysis of this anomaly showed that this kind of phenomenon can occur when water vapor molecules are ionized by sunlight. This means that the Galileo spacecraft didn't just fly near a water vapor eruption from beneath Europa's ice, but flew directly through it. Later, the Hubble Space Telescope, when studying the icy moon, provided new evidence of geysers on its surface. In 2013, it managed to take several photographs of the moon, where it is possible to spot traces presumably left by giant geysers in the lower left section. Scientists believe that these geyser jets reach several hundred kilometers before crashing back down to the moon's surface. According to calculations, every 8 minutes, enough water is ejected from beneath the ice to fill an Olympic swimming pool. Indeed, there is plenty of liquid water out there. The depth of Europa's subglacial ocean may reach 60 miles, and its total volume likely exceeds double the volume of Earth's oceans. Geysers are not the only clue scientists have. It was recently established that Europa's crust rotation speed varies. Sometimes it moves faster, sometimes slower. This means that the crust's movement differs from the speed of rotation of the moon's internal part. The cause is attributed to the gravitational influence of Jupiter. The tidal forces of the gas giant cause deformation, which makes the icy crust slowly and unevenly slide over the subglacial ocean. This is direct evidence that between the icy shell and the solid core of the moon, there is a vast ocean of liquid water, which makes this chaotic movement of the icy shell possible. Additionally, Jupiter's gravitational force may also be a source of energy for the subglacial ocean, keeping it in a liquid state. The side of the moon closer to Jupiter experiences a stronger gravitational pull from the gas giant than the opposing side. This creates a stretching effect, causing fractures to appear on the surface of Europa, fractures that were first seen in photos shot by Galileo. Moreover, it is likely that the moon is heated from within due to tidal processes and friction caused by its flexing. Galileo also detected a strange disruption in Jupiter's magnetic field structure in the space surrounding Europa. This anomaly suggests that the magnetic field is distorted due to its interaction with an electrically conductive liquid beneath the moon's surface. Based on Europa's icy composition, scientists believe that the most likely material responsible for this magnetic signature is a global ocean of salt water hidden beneath a massive ice sheet estimated to be about 10 to 15 miles thick. Any radiation or other external influences cannot reach this water world, which means there is no threat to potential life and its evolution. But why do scientists believe that, in such extreme conditions, far from the sun and under a thick ice layer, it is nonetheless possible for extraterrestrial life to exist? And how complex might it be? In March 1979, two NASA space probes, Voyager 1 and Voyager 2, moved along a trajectory near one of Jupiter's moons, Europa, as part of the Solar System Exploration Program. At a distance of 118,000 miles from the moon's surface, Voyager 2 took a number of high-quality images and conducted measurements that led scientists to hypothesize the existence of a liquid ocean beneath the thick ice shell of the moon. All subsequent research, including the data collected by the Galileo space probe in the late 1990s, while studying Europa at the height of 124 miles above the surface, only confirmed the existence of a liquid water ocean beneath the ice, which is between 6 to 18 miles thick. Soon, thanks to the space probe studying Europa, scientists were able to discover something that gave them solid grounds to suggest that life might exist on this moon. On October 14th, 2024, NASA launched the interplanetary mission Europa Clipper. This spacecraft is set to travel to Jupiter's moon and conduct detailed studies of its surface and subsurface ocean. This is NASA's most expensive planetary mission in history, the largest space probe ever designed for studying a planetary body, and the most ambitious mission in the search for extraterrestrial life in human history. What are the chances that we will discover extraterrestrial life? What exactly do scientists plan to find beneath the ice? And why has Europa Clipper become the most expensive project in NASA's history? Europa is one of the 95 moons of the gas giant Jupiter, a mysterious cold world with a diameter of 1,940 miles, which is about 90% the size of our moon. Entirely covered in ice, exposed to incredibly intense cosmic radiation, and with extremely low surface temperatures that drop below minus 50 degrees Celsius, it may seem like a barren dead world at first glance. Yet, this icy moon is considered one of the most promising places in the search for extraterrestrial life. Here is why. In 1997, while following an extremely low trajectory, just 125 miles above Europa's surface, the Galileo spacecraft managed to capture an extremely strange phenomenon. In one section of the moon's surface, there was something resembling a water vapor eruption. At the same time, scientists observed an anomaly in the readings from Galileo's magnetometer. Analysis of this anomaly showed that such phenomena could occur when water vapor molecules are ionized by sunlight. This means that the Galileo spacecraft didn't just fly near a water vapor eruption from beneath Europa's ice, but flew directly through it. Later, the Hubble Space Telescope provided new evidence of geysers on Europa's surface. In 2013, it managed to take several photographs where it was possible to spot traces presumably left by giant geysers. Scientists believe that these geyser jets reach several hundred kilometers before crashing back down to the moon's surface. According to calculations, every 8 minutes, enough water is ejected from beneath the ice to fill an Olympic swimming pool. Indeed, there's plenty of liquid water out there. The depth of Europa's subglacial ocean may reach 60 miles, and its total volume is likely to exceed double the volume of Earth's oceans. We tried Titan, the largest of Saturn's 14 moons, is even bigger than Mercury, but it's no ordinary satellite. The gigantic moon is so similar to Earth, it's almost hard to believe. Not only does Titan have lakes, seas, and rivers, but it also hides a subsurface ocean of water below the icy ground. In the moon's skies, there are clouds. On its surface, organics rain on Titan, replenishing lakes and seas and then evaporating, launching an Earth-like hydrological cycle. The atmosphere of nitrogen and methane that envelopes the satellite is thick enough for you to safely stroll around its surface without a pressure suit. But that's only if Titan weren't as cold as minus 290 degrees Fahrenheit and had an oxygen-nitrogen atmosphere like Earth. If you had wings attached to your suit, you could even fly, as the moon's gravity is just 14% of Earth's. Because of this, you would also witness its rain falling in slow motion, about 6 times slower compared to Earth. Although it would be no ordinary rain on Titan, it rains liquid methane, and its droplets are roughly 50% larger than raindrops we see on our planet. Titan is located some 750 million miles from Earth, where it revolves around Saturn in about 16 days. Titan is tidally locked to the sixth planet, but even though one of its sides is always facing Saturn, the satellite still has intricate weather patterns. Saturn's largest moon receives 100 times less solar energy than our planet, and it has a thick atmosphere extending 10 times higher into space. In these conditions, not much light can get through and reach the surface for the first half of Titan's day, which is equivalent to 16 Earth days. Its surface is bathed in a faint orange haze. Looking through this haze would be like trying to see beyond thick fire smoke. The skies during this part of the day could be 100 to 1,000 times dimmer than here on our planet in an afternoon, and the other part of the day brings total darkness to the surface. But even if it was bright enough, you still wouldn't see Saturn from the surface of Titan because of the haze. Interestingly, daytime isn't the brightest part of the moon's day. According to computer simulations, the brightest it gets on this mysterious world is during twilight, up to a factor of 200 compared to daytime. This is something that happens because of the way light is scattered by the haze particles in the atmosphere. Since Titan is tidally locked with a permanent daylight side and night side, there is also a permanent twilight zone, a border between the two sides called terminator. Titan, like Earth, experiences eclipses, which can last up to 6 hours. This is like having a second night in the middle of the day. Of course, you would only notice it if you were on the side of Titan facing Saturn. Otherwise, a solar eclipse would happen during nighttime. Understanding this is important, as it tells scientists how much light Titan's atmosphere and its surface receive from the sun, which dictates what conditions potential life on Titan would have to live on. Just recently, the James Webb Space Telescope was able to detect clouds that form in Titan's lower atmosphere during late summertime, when its surface absorbs more heat. This means that the moon has seasonal weather patterns. Just like scientists have predicted, Titan's tilt relative to the sun closely resembles that of Saturn, so both celestial bodies experience seasons of approximately equal duration, changing about every 7 Earth years. Although at a slow rate, seasonal shifts bring changes in weather on Titan. When the Earth's axis is tilted neither away nor toward the sun, something interesting happens. Imagine a line that cuts through the north and south poles, dividing the planet in half. During this time, occurring twice a year, night and day have about the same length all over the world. This phenomenon is called the equinox, and Titan experiences it too, although less frequently, about every 15 years. But when this time of the moon's year comes, enormous clouds of methane form in its equatorial regions, bringing about severe windstorms. During summer on Titan, the wind blows stronger. During the Cassini mission, scientists saw waves on Titan's lakes, and they were unlike any waves here on Earth. Titan's weak gravity allows these waves to be much bigger, about 7 times taller than waves in Earth's oceans, but they move more slowly, up to 3 times slower. Winds on Titan also fuel powerful dust storms. Something like this happens in arid areas on Earth too, when big dust clouds form right before storms. The only other place in the solar system where this phenomenon has been detected is Mars. This is how organics, in the form of dust, are scattered around Titan's surface. Although downpours are a rare phenomenon on Saturn's largest moon, when they do happen, they leave behind a fascinating footprint. Titan's rains are heavy and have a big impact on the surface. They create something called alluvial fans. These features are a bit like piles of dirt and rocks shaped like triangles. They form when water or ice flows and leaves behind the stuff it was carrying. Scientists have also detected dune fields on Titan, taking up to 13% of the moon's surface. Compared to sand dunes found on Earth, they are enormous in size, hundreds of miles long, 1.2 miles wide, and 330 feet high. There's more sand on Titan than anywhere else we know of. Although this sand isn't made of silicate, like it is on Earth, it consists of solid hydrocarbons that fall like rain from the atmosphere. On Earth, we understand how landforms are created through a straightforward process. Rocks break down into tiny grains. Wind carries these grains to specific areas, they pile up, and eventually, they shape the land. But on Saturn's largest moon, things are more puzzling. The origin of its landforms has been a mystery because the sand grains on Titan, AC, different from those on Earth, are weaker and thought to be more temporary. However, despite this, we've observed long-lasting sand dunes on Titan. When the wind transports sand grains, they should collide with each other and the surface, which usually makes them smaller over time. So, how do these grains manage to stick around long enough to form significant landforms? After studying Titan's landscape, scientists discovered something fascinating. It turns out that the moon has a special type of sedimentary process known as sintering, where neighboring grains smash together and fuse into larger, stronger pieces that are less likely to be blown away by the wind. If sand on Titan can adapt in such a way to form complex landforms, could life have adapted similarly? There are a lot of similarities between our home planet and this alien, faraway world. The problem with Titan is its ingredients seem to be all wrong. What's water on Earth is liquid methane and ethane there, including its clouds, rivers, lakes, and seas. But one thing is certain, this celestial body is still active. Even liquids flowing on the surface of Titan involve complex physical processes similar to water bodies on our planet. Methane lakes on Titan can stratify, that is, create layers depending on density differences. And not only that, but the liquefied methane and ethane lakes could potentially erupt. This happens due to the combination of methane, ethane, and nitrogen, resulting in bubbles powerful enough to shape river deltas within the moon's liquid bodies. Understanding how bubbles form in Titan's lakes helps scientists explore how liquids behave on this intriguing moon. Imagine if a submarine was sent to explore Titan's lakes one day. If it gives off heat, it could actually cause an explosion of bubbles, just like the one scientists have discovered. So, these findings not only tell us about Titan, but also hint at some surprising challenges future spacecraft might encounter in those alien waters. Whatever life forms could potentially exist there, they would have a completely different biology, and so they would look and act like nothing we've ever seen before. According to a team of researchers from Cornell University, it's possible for cell membranes to form in the conditions present on Titan. Right now on Earth, cell membranes are made up of special molecules called phospholipids. Imagine these molecules as having a head and tail. The head is a bit like a magnet with a positive and negative side. The tail is neutral, meaning it has no magnetic quality. Imagine these molecules in water, like a sandwich with two slices of bread. The heads of the molecules are like the outer sides of the bread, and they really like the water, so they face outward. But the tails of the molecules are like the inside of the bread, and they want to stay away from the water, so they hide in the middle. This arrangement makes the membrane flexible, something that's crucial for life. If there's any form of life on Titan, it would probably need to have a similar membrane. The problem is that methane has an even distribution of electrical charges, so Titan doesn't have the right conditions to make these Earth-like membranes. Because of this, life on Titan would have to find a different way to build its cell walls. But scientists have been able to create inside-out membranes in such nonpolar liquids in a laboratory, and they believe that Titanian cell membranes would have a similar structure, although they would have to be composed of something else. As liquids on Saturn's largest moon probably lack phosphorus and oxygen and are too frigid for phospholipids, what kind of a molecule could this be? Although the Titanian atmosphere is mostly made of methane and nitrogen, it has traces of different compounds as well. Computer models have shown that a substance called acrylonitrile would be able to form cell membranes in a nonpolar liquid methane on Titan. The Cassini mission has previously detected small amounts of acrylonitrile in the Moon's atmosphere, about 10 parts per million. Even though there's a vast difference in temperature between where Earth-like membranes form and where Titanian membranes could form, they both share surprisingly similar qualities, like stability and internal resistance to external forces. So, it's possible for membranes to form in the frigid temperatures of Titan lakes and survive there. The possibility of methane-based life would change our entire outlook. Instead of focusing solely on planets in the habitable zone of stars, where conditions are Earth-like, we'd also explore worlds farther from their stars, where methane can exist as a liquid. Within our galaxy alone, the number of potential places to find alien life forms would skyrocket. And if life on some of these worlds has persisted for long enough to develop into complex organisms, we might find a living counterpart of an imaginary creature, like those mentioned in fantasy movies and books. But even if, at this late stage of Titan's history, life cannot survive on its surface, there's a subsurface ocean of liquid water hiding beneath the Moon's icy coating. Scientists are trying to find out if organics can penetrate through this ice shell into the ocean. If this is something that happens on Titan, then this subsurface water could be potentially habitable, although we still don't know much about its density, composition, temperature, and how it interacts with the icy crust above. Another big question is whether there's a source of chemical energy down there to allow for metabolism. But one bacterium with a rare metabolism that's been found on Earth could potentially live in Titan's subsurface ocean. Billions of years ago, Earth had a very different atmosphere, with high amounts of nitrogen, CO2, and water vapor, which descended to the surface, launching a life cycle. The building blocks of life on our planet may have once been the same ingredients we see today on Titan. In a way, Saturn's largest satellite is a real-life lab where astrobiologists can study how these ingredients might have played a role in the beginnings of life on Earth. Perhaps some millions or billions of years into the future, the Moon will evolve into a habitable world teeming with Earth-like organisms. Soon, we may find out the answer to these questions. Planned to be launched in June 2027, NASA's Dragonfly robotic helicopter will search for water or hydrocarbon biosignatures potentially present on Saturn's gigantic satellite. With Dragonfly's arrival, scientists hope to uncover clues about Titan's subsurface ocean, its potential habitability, and whether the ingredients for life might indeed be present in this distant world. If we discover signs of alien life on Titan, what might these otherworldly creatures look like? Share your thoughts in the comments below, and stay tuned here for the thrilling discoveries that await us in space. Thanks for watching.